Hello and welcome to Mill Lab number 7. Today we're going to be doing this part over here real quick. What we've got is we've got a part that's 5 inches by 5 inches squared by 1 inch thick. We've got some radii on the outside. We've got some chamfers right here. These chamfers are 1 inch by 45 degrees. Go over here real quick. That means the distance from there to this point right here is 1 inch. So it's 1 inch up and 1 inch over, 1 inch over, 1 inch down. Uh, so we've got that going on there. We've also got, we're going to finish mill that. Okay. Uh, we are going to do a pocket, and we're also going to do a bolt hole circle right here. So we'll come back to that as it goes into. I'm not going to spend a whole lot of time explaining every single thing that we need to do with all this. We can come back to it. All right. Well, of course, we'll be leaving stock on X and Y for the outsides, and then finish milling that. We'll be leaving stock on the inside of the pocket, and then finishing that too. And we'll be doing this. We'll be doing the outside with 2 separate end mills, a roughing mill and a finish mill. I will be doing the inside of the pocket with 2 separate end mills, a roughing mill and a finish mill. Uh, this gives us a little better part geometry. All right, so there we go. All right, so I've got my startup block here. And notice this is in English, so the G20 is activated there. We're going to start with our G54. X0, Y0 will be in the lower left-hand center of the part right there. Okay, later on what we're going to do is we're going to shift the work. We're going to do what's called a work coordinate shift, and we're going to shift the X0 and Y0 to the center of the part. We'll be using a G55 to do that. All right, and that's a pretty common thing. We do that a lot. Most controls, excuse me, most controls have a at least 20 or 30 different fixture or work offsets. So you got a G54, 55, 56, 57, 58. You can just go on depending on how many you need. They'll support that many. So you can shift the X0, Y0, and even the Z0 anytime during the program. It makes programming a little simpler, and you'll see what I'm talking about, rather than always coming from the same place. Now, if I was doing this with CAD CAM, we wouldn't care. I really wouldn't care. I would probably just set it up in the center of the part and be done with it, because it does all the math. This will make our math a lot easier by shifting our X0 and Y0 halfway through the program. So that's what this is. This is going to be with a work coordinate shift. All right, so we'll take a look at the instructions. Here they go. I will post these. Uh, Again, yeah, we're going to use cutting speed of 70 on all operations. First tool is going to be a 6 flute 7/8 end mill with a feed per tooth of 2,005 tenths per revolution. We're going to rough mill it 2 equal depth passes, leaving 20,000 stock. And then we're going to use a 4 flute 3/4 finish end mill with a feed per tooth 4,000. So we're going to finish mill the outside contour, leaving no stock. Then using a 4 flute 5/8 end mill with a feed per tooth 3,000. So we're going to rough mill the 1 inch 750,000 diameter pocket, 250,000 deep, and 2 equal depth passes, leaving 20,000 finished stock on the sides, both in X and Y, and 10,000 on the bottom. Okay, in Z. We're going to then use the same tool that we used here in step 3, exact same tool, with a different feed. Okay, and we're going to finish mill that 750,000 diameter pocket, 250,000 deep. Then we're going to drill these holes. Okay, so we'll get back to all that. So let's minimize that, get it out of the way. So we've got our startup block here. First thing we need to do is go ahead and we got tool 1, we got an MO6. I've already got 7/8 end mill, 6 flute put up on there. We're going to put our spindle speed. Let's get our spindle speed. So we'll calculate that one more time. Pretty soon I'm not going to do this anymore. I think this is the last time I'm going to be actually calculating these for you. So 70 times 3.82 equals this, divided by point. It was 7/8, so that's 875. Okay, so 305. That'll be fine. We'll copy that and we'll paste it right there. Boom. And we'll hit Control S. So there's our spindle speed. H1, N1, this is all good. 25.4, no, we don't want that because that's left over from a metric program. We want to go down to 1 inch like always, Control S, because we wouldn't want to stop 25.4 inches. You get a over travel error because very few machine tools or milling machines are going to have that much travel in the Z-axis. All right, so standard stuff, we're going to go to X0, Y0, Z.1 and turn the coolant on. Okay, so now let's go ahead and move to our safe start position, which, it's going to be half of 7/8, so half of 7/8, clear that. 0.875 divided by 2, and believe it's probably going to be 7/16. It is 500 thousandths, will be fine. So we'll go to our safe start. So x, remember, x minus 0.5 space y minus 0.5. Okay, at that particular point we moved over there. That is our SAFE START safe start position. Control S if you haven't done that. New line in 50. Okay, so now we want to go ahead, we're going to bring Z down, G01, because remember the G00 is activated and we don't want that. You can make that a G1. Let's just do it again. G1, Z is going to come down. I'm going to go to 500 thousandths. That'll be no problem with a 7/8 end mill. It won't. Minus 0.5. That's all you have to put on there. Remember, no such thing as a G1 without an F. Now we have to calculate our feed. So let's calculate our feed real quick. That was a 2 thousandths and 5/10. I want to double check that. 2 thousandths and 5/10. Yes, right there. 2 thousandths and 5/10 per. So, so let's try that again. Go in here. So we got 6 flutes this time. So 6 times 0.0025 equals this, and then multiply it times, looks like 305. I've got a decimal point up there. It's not going to work. Times 305. I'll show you what I'm talking about. So that's it. This is not going to work. Never put a decimal point in there. 305. That will not work. Control S. All right. Now, let me see. What was that feed again? It was, I can copy this. I'll go 4.58. That'll be fine. Control S if you haven't done all that. So let's double check we got our tool number right. We got our spindle speed right this time. Remember, no decimal point in the spindle speed. It'll error out. Then we move to our safe start position. Z's come down. There, we've got that going. So new line in 60. Control S. So space over. So we're going to go ahead and let me point out the points here. Let's get a little click here and get this stupid thing going. So there's point 1, point 2. You know what I'm going to do here? I'm going to do something else. I'm going to zoom in here real quick. Do my marquee zoom. We don't need the top at all right yet. Okay, we just need this there. That'll be easier for you. And I'll go over here and do that. Do this stupid stuff. So I have a point. So this will be point 1, point 2, point 3, point 4, point 5, point 6, point 7, point 8. Now I'm going to come and start right here. I'm not really going to call that a point. You know what? We'll just call that point 1. We won't worry about this. Will be point 2, point 3, point 4, point 5, point 6, point 7, point 8. Now we're going to clockwise. We're going to mill in a clockwise direction. That'll make it so it's climb milling. Remember, all our tools are right-hand tools, so it's rotating in a clockwise direction, so that'll make it climb milling. We always want to climb mill. So anyway, let's go ahead and just do it. Get that out of the way. Always great. There. Okay. So we got our Z down, we got our spindle running, we got our coolant running. It's time to comp over. So this is going to be comp left. So again, I'm going to give it a G1 just for G41. That's cut or comp left. And let's see, we're going to move X to 0, X 0 point. And we're going to use D1. That's going to be the first one we put there. D1 is going to be point. Now we're going to rough, right? So we're leaving, so we want 40 thousandths more per side. So I have to do that. Can't do it in my head. 7/8 is 0.875 plus 0.04 equals, that's 0.915 in control. That means that's what size we are going to put in the tool geometry table of the control. So the control, remember, this is going to leave a stock, because what we're going to do is we're going to rough mill it, then we're going to finish mill it. Control S if you haven't done that. So 915 thousandths in control. Yeah, okay. Clear that again. Make sure 0.875 plus point. Oops. Clear it. Plus 0.04 Yep, 915. Okay, that's the diameter that we'd put in there for D1. All right, new line, Control S if we haven't done that lot. 970. Here we go. Okay, so at this point, it should, now we're just going to take our next move. Now, what we're going to do is, since we've got this is here, we're going to have to actually do a little extra milling here. This is going to be some interesting stuff here. Um, let's go ahead and, so we're down here at X0, so we need to show it where to go. So I'm just going to go right to here. So we'll call that point 2, which is going to be, remember this is an 875 thousandths radius here. Let's move this back out a little bit to, let me 75. Yeah, there we go. Come over here. It's an 875, so it's 875 thousandths from there to there. Remember, that's what that radius means. Okay. 875 from here to there. It's 875 from there to there. So this actually starts at 875 thousandths. So let's go ahead and do that. So we've already got it in G1. So all we have to do is move a Y. Y is going to go to 0.875. You do need to take that out to 3 places because that's where we want it to be. Remember, 5 is a significant digit, so don't do that. Don't leave that out is what I'm trying to say. Control S in 80. And now we're going to go to this point up here. I'm not even going to number them anymore, and I'm not going to keep doing that. It's this point right here. So how do we come up with this point? Well, we know it's 5 inches minus 1, because this is 1 from there to there and 1 from there to there. So it's going to be, that is going to, we might as well just head right on up to Y4. Now, a lot of people would say, why did you put that in? Why didn't you just go to Y4 right here? There is a reason for that, mostly because I'm teaching. Normally I would go right to Y4. If you single block, you're going to get a divot there or something like that, a little dip, but that'll be fine. So Y went up to 4, Control S if you haven't done that. New line in 90. Okay, so now we're going to go to this point right here. So let's see. Well, we know that is X is going to be 1 inch, because that's what that is. That's a 1 inch chamfer. So X is 1 and Y is 5. Okay, Control S, new line. Okay, now we're going to go to this point here. So all we have to do is move our x-axis. So this is 1 inch from there to there. I do want to show you something, a little print reading here. This says 1 inch by 45 degree chamfer, TYP. That means typical, and that means that any feature that's exactly the same, so this feature and this feature are both this dimension. It's just a way of making the print a little easier to read. Okay, so we know it's 1 inch from there to there, so that's x 4 inches is where we got to go. X 4.0, Control S, new line. Okay, so now we want to move here. We're going to move both. X is going to go to 5, and Y is going to go to, well, guess what? 4, right? It was before. 4 before. The English language. Okay. So yeah, that'll get us to right there. Now we want to come down here. So in 120 space, we're going to just move our y-axis. So y is coming down, and remember, if it's a radius, it's 875 from there, from there, from there. So y is going to be 0.875. We're going to go to y 0.875. Okay, new line. The Control S. Okay, at this point it's time for a GO. Now let me see, which direction are we going? We're going, that's clockwise, so that's a G02. G02 is arc counterclockwise. Remember, you tell it where it finishes. So right here, GO2 from there to there. So X is going to be 5 inches minus 0.875, so that's 4.125. So X 4.125. And Y is going to go to 0, and our R is going to be 0.875. Now we got the same feed rate, so everything's good. Control S, that'll cut that radius. Okay, we're right here. This is where we stopped. New line. Looks like Control S. I don't remember if I did that. Anyway. Alright, so now we're going to go to this point here. So we're going to move X alone. But we do have to go back to a G1. Now, I can come back up here. Instead of making that a G02, G2 is fine. All right, now G12, G2. Fat fingers. Control S. G1. So we're going to G1 back to X 0.875. Now, this is why a lot of people should be taking print reading classes, because I know some of you are going, how does that work? Well, if you take a print reading class, it becomes pretty obvious how it works. Control S. Okay, that is a straight line, so I had to go from that. Now, I'm right here. Now, I'm going to go ahead and cut my radius. All right, I'm going to go ahead and cut my radius. Now, so in 150, this is going to be, well, let's see, we're again going clockwise, so that's a G2. Clark, arc arc clockwise. Boy. Okay, so G2, X is going to finish at 0. X is 0. Y is going to be 0.875. R is going to be 0.875. Thought ought to do that. New line in 160. Now at this point, if I stop right here, I'm going to have a divot in the part. So I either need to move up a little bit, then move over. I need to get past this point. Now that means since I'm roughing, I don't care. Now later on, I think we're just going to arc right off of that position. We're still going to have to go up some. Man, that's all there is to it. You're going to have to go up some. So let's go back to G1. And you know how much? That's up to you. I certainly wouldn't go to the center of the part. That'd be nuts. Okay? Just realized I left these lines here. They weren't supposed to be here. Those are center lines. They should have been center lines. I didn't draw that correct. Had a lot of trouble yesterday just getting this to print. It's just horrible. Spent 3 hours on this drawing that normally would take me like 45 minutes or less. Matter of fact, I could probably draw it in 20. Alright, so anyway, let's just go G1, and Y is going to go up to 2 inches will be fine. Right now, we're just going to get it past this point here so that now we are double cutting that, but remember we're roughing, so who cares? Nobody cares, I guarantee you that. Okay, so good, Control S. In 170 space. Okay, now what we want to do is we're going to go ahead and comp over to X minus, what was our safe start, was X minus 0.5. So we're going to go over there. Okay, and let's turn our comp off. A lot of you have not been turning your comp off. Like I said, Y, we're going to want a G40 there. If you don't turn the comp off, it won't work. You got to make a move. And G40, Y minus 0.5. At that particular point, Control S, it would have come over here, and come down here. Because remember, half of this, you have to have an approach. So I can put cutter comp on. We'll go ahead and do that up here. Let's see. Yeah, 915 thousandths in control, cutter comp on. I'm going to put cutter comp off. Cutter comp off right there, Control S. That turned the cutter comp off. I'm going to open up a line, I got some other stuff down here below it, so later on that I saved. I'll show you what I'm talking about. Now, so what do we need to do? Well, we just need to copy all of this again. Now, it's already at here, so this is really all I need. I'm going to copy all of this because it's already at X minus 0.5 and Y minus 0.5. Okay, copy. This is going to be my second pass. Paste. So what do I have to change? Well, I still want, this is my second depth pass. The only thing right here is I want it to go to 1.01. That'll be fine. Control S. Everything else should be fine. That's the beauty of that cutter comp, this diameter offset thing. I just made a whole nother pass. I didn't have to do anything but cut and paste. So now I've taken 2 passes. Here's my first pass, leaving 20 thousandths. Here's my second depth pass, leaving 20 thousandths on all axes, both X and Y, not in Z. Okay, and so now let's go down here and open up another line there by hitting enter. Okay, I hit Control S just in case I haven't done that. At this particular point, I want to now I have to do a tool change because I am going to use a different tool to finish. So I'm going to go back up here to my tool change block, and I'm going to go ahead and get all of this. And copy. Come back down here. Okay, and paste. Now there's some other things I want in there, right? There is. First off, the cutters, what I've got here is it, I didn't turn it off and I didn't put an optional stop in there. So I'm going to do this. And this is, so we'll turn our spindle off and we'll go ahead and what else will we do here? We'll turn spindle off. We'll do, you know what? I'm going to do this first. I'm going to put my G28. I don't really need a G. Yeah, you do. You need a G28 after you've been roughing. That's all there is to it. So G28 Z 4.0. So all access will go home. I'll turn it off even though I know I don't need to. That can be just an M5, by the way. This can be an M3, by the way. Oh, doing some stuff here, moving around. M5. Okay. And how about an optional stop? And that can be just an M1. Control S if you haven't done it. So yeah, so there we go. Yeah, that's how we finished that. We did our G28, sent it home, turned it off. Now, the tool change would have turned it off anyway, and even the tool change, but the G28 is very important because it does help recalibrate the machine. Remember, after taking big rough cuts, the machine's going to develop some following error, so this is a good idea to do that. Okay, let's see if there's anything else in there that I don't need. Okay, so we're going to go Tool 2. So we change our H number immediately to 2. Our spindle, this is not going to be, I have to look at our instructions to see what I said, using a 3/4 end mill and a feed per tooth of 4 thousandths. Okay, so let's minimize that. So this is going to be a 3/4 end mill, and it's not going to be 6 flute, 3/4, 4 flute, Control S. Okay, RPMs, well, obviously I do have to do that. So 70 times 3.82 equals this, divided by 0.75 equals that, 356. Not a big change in speed, but hey, whatever. I'm not going to copy and paste that because we saw what happened last time. I ended up with decimal points. You don't want decimal points there. Control S. So let's see here. Spindle on through. Yep. It's 2. We got all that looking pretty good. So that's our good. There's our tool change block to tool number 2, which is the 3/4. So we've got all that. What do we need? Well, we just need to make one finish pass. All right. So the finish pass, the easiest ones to copy is this last block, right? Bunch right here. So let's bring all this down here. We're going to add some more stuff, but copy, paste. So Z, that's still good. The feed, we didn't change the feed. I need to change the feed. Let's see, what did I told it again? 4 thousandths per revolution feed. Okay, so again, we got 4 flutes, so 4 times 0.004 equals this, and then multiply times the RPM, which was 36 times 356 equals 5.69. So my feed is going to be let's just say 5.7 will be fine, especially for what we're doing here. Control S if you haven't done that. Now, this we got to change our D number. We're going to use D2. Okay, this time it's going to be, we're going to put the actual diameter. And let's say you're using a brand new end mill, so it's actually going to put 750 thousandths in the control. All right, all of this should work. Okay, I did everything. And actually, there's some things here. Since I'm using 750, I only use 3/8. My safe start position, right? Let me see. Oh, that's some other things I need to put in there. That's right. I need to get it into the safe. It's already at, nope, it's not. So let's open up some lines here. Enter. Go up. Let's see. In 40, we will resequence here. I'll do that pretty shortly to make sure that everybody's on the same page. So in 40, we want to go to, I don't really, yeah, we'll do it. X, you know what? I don't need to type this in. It's up here. Right here. All this is right here. It's even, yeah, see? It's right there. Copy. Yeah, why do that? Okay, so let's see. Paste. So we went to x0, y0, z.1. Now these safe start positions are a little, they're a little big, because actually for 3/4 we only need 3/8, so it could be 0.4. So if you want to save, again, on one part, nobody's going to give a damn. On 5,000 parts or 500 parts or what have you, this is going to make a big difference. Time savings, Control S. Okay, so yeah, safe start. Z came down, we got the right. I'm double checking this as I go. I got my cutter comp on, D2, 750 in control. All of this, we're assuming all of this is pretty good. I'll run it. I'm sure it is, though. It's pretty standard stuff right there. Uh, okay, yeah, that all looks pretty good. I'm going to leave that alone just like it is. Get the M5, the N1. So that's my finished pass right there. I made my finished pass. So we made one pass at Z minus 0.5, leaving 20 thousandths in both the X and Y. Another pass at Z 1 inch and 10 thousandths, so we get past it, leaving 20,000 stock. And then tool change, we went to a different tool. Yep, we sure did. And then we went ahead and made our third pass, leaving no stock. So this is our finished pass right here. You know, make sure. Oh, there's something else I forgot to do right here. This is something I seem to forget to turn my coolant off a lot. That's interesting. At this particular point, I'm going to do the same thing here. Yeah, and yeah, that's an M9. You don't have to put M09, M9. That'll turn that coolant off there. Is there any other place that I had a G28? No, that was already, all that one is down there, so I left the coolant on. That definitely, yep. So I turned the coolant on here. I moved to my safe start position. Z came down. There we go. We did all our all our contour coordinates. The G2. Yep. G28, Z4.0, M9, M5, M1. We're good. Okay. At this point, I think it's probably a good idea. Control A. I'm going to resequence it. Uh, and oh, okay. Yeah, that's what I was pointing out. That had a whole bunch of stuff here. Let's get rid of all this. This is just stuff that was in another program that I copied over and I want to get rid of it. So I'm just deleting it. Delete, it's gone. Very good. Okay, now hit Control A. I hate that that does that, but there it is. And of course, we're going to copy it. Now we're going to open Predator Editor. So I can resequence this just to keep everything straight. Paste it. Paste it. I'll try it again. Paste it. Did it? It did paste. Gosh knows how many times I just pasted it. So I'm going to hit Control A, delete it, and I'll paste again. Yeah, I don't like that it does that, but it does. Process, resequence, we'll put down OK, boom. Bring this back up here. And I'll hit Control A again and copy that. Close this out. No. Okay, go back over here and just paste over top of that. Now and hit Control S, and I should have all nice resequence numbers. Let's double check. Yeah, that's much nicer. Yeah. Okay, great. And we got rid of all that other stuff down there. I should have got rid of that before. I was going to save it for some reason, but it doesn't going to make any sense to save it. All right, at this point, what I have done is I have just finished milling the entire outside. All right. Now remember, none of this assumes clamp shifts or clamp jumps or anything like that. We just mill the whole outside. And so I could put in, I could finish this up, but I'm not going to finish this up. What I'm going to do is it's time for our work shift. So we're going to do another tool change. So let's go back into our instructions. Okay, using a 4 flute 5/8 end mill to feed per tooth 3/1000 rough mill to pocket. So yeah, we're going to do it. So that's a 3/1000 feed per tooth. Need to write that down, and a 5/8 end mill. All right, so let's calculate up our RPM first. Let's minimize this. Okay, clear this. So 70 times 3.8, oops, not 82 equals this, divided by 0.625, that's decimal equivalency of 5/8, 427. So that's how fast we're going to run that. It's 427. So let's just leave that alone for right now. What do I need to copy? Well, I need to copy a tool change, right? And actually, I'm going to copy all of this right down to there. Now, I already got that M5 and that M1 there, but I copied it. Let's see what that does. Paste. Bring that over here. All right, I got two M5s and two M1s. Obviously, I don't need those, and get rid of those. Delete them. Delete. There. Leave one line. Control S if you haven't done that. This would be tool 3. Go down and change that H number to 3. Okay, spindle speed. I can't remember what it was. That's okay. I left it there. It was 428. All right, just round it. 428. And I'm going to leave that in there without clearing it. Okay, Control S if I haven't done that. So let's see. We turn it off, turn it on. This goes up. This is we're going to change. This is where we're going to do this. Now we're going to do a activate work offset, and I'm going to call it a work offset shift, because we're going to shift our X0 and Y0 to the center of the part. And how we're going to do that is we're just going to change. It's simple to program. You have to set it up with a control. I'm going to change that to a G55. That's right. Now what that does is when it reads this G55, the control will go into the G55 and say, okay, and it'll tell it, oh, I'm moving my X0 and Y0 to this position. Okay, so now it's in the center of the part. So now, effectively, I have shifted. Now this is a setup thing. It's not something that you can do in program. Like I said, it's simple to program. Activate work offset shift. And here, let's just put this in here. So we all know what's going on. Activate work offset shift to center of part. This is done a lot. Especially if you got multiple parts and you're setting them in multiple fixtures, you can shift your zeros. It's not that hard, and boy, it sure looks slick. Control S if you haven't done it. Okay, so I've gone ahead and maybe to make things a little bit easier, done some things ahead of time. What I'm going to do here is we're going to mill out this pocket now. We're going to rough mill it, then we're going to finish mill it using 2 cutters. We're going to use the same 2 cutters as we used to do the outside. If we go back up over here, click and go back up, we can see that our first cutter here was a 7/8 end mill, so we're going to use that 7/8 end mill, and then we're going to finish it with a, I believe, yes, tool number 2, a 3/4 end mill. So I've copied and pasted some stuff in here just to get this going. All right, so we're going to use tool number 1. So we'll change that to T1. All of this is going to be the same. Remember our work shift. We've done our work shift thing there. So we've X0 and Y0 is now in the center of the part. Let's make this H1 as well. Okay, and let me see, how fast did we run? Tool number 1, we'll copy that real quick, 305. So let's copy that. Go back here down to tool 2, let me see, here we go, here, tool 1, excuse me, and we want to paste our RPM right here. Paste. In the next videos I will not be calculating any RPMs, any feed rates, any drill point lengths, depths, things, etc., tap feeds. You're going to be doing that all yourself, and from now on, as a matter of fact. So I've got that in there. Hit Control S if I haven't done that. So this is going to be a 3/4, no, excuse me, this is a 7/8 6 flute, as I recall. Yeah, and it's definitely going to be center cutting. Remember, center cutting means we can plunge this directly into the work like a drill. All right, so we've got this. That's all good. H1, T1. Let's go up and get that feed for tool number 1. Here's our feed. It's 4.58. I'm just going to copy the whole thing. Copy. Come back down here. So again, what we're getting ready to do is we're going to go ahead and, like I said, mill this pocket, and we're going to rough mill it first. Pocket rough mill. That's what we got. So the feed is right here. Here we go. Paste. All right, so let's explain what's going on. First off, I've got it going to the center of the pocket. I really don't want to do that because I want to use cutter comp. So I'm going to go to a Safestart position 2, or as well, excuse me. So we're going to make this it could be on one side, y, x this way or x that way. Uh, Excuse me, I want y to be 0. X is the one I'm going to change here. So let's change x to, heck, we'll make it positive. Again, it has to be a move greater than the, we have to give it a distance greater than the radius of the cutter. Half of 7/8 is 7/16, so that's 500 thousandths will be fine. So if I go x.5, hit Control S, that ought to give me enough room. All right. So great. So I'm moving to x.5, y0, z.1, mo8. Remember, this is also my safe start position. I'm not going to put all that in there because I already got a bunch of, yeah, I do. I got pocket mill safe start already in there. Okay, very good. Um, so Z is going to come down to 240 thousandths. Remember, we're roughing, so we're leaving 10 thousandths on the bottom right here. And now we want to move up. Now these numbers aren't, I copy and pasted these out other places. So first off, we want to come up half the diameter of the cutter at least. Okay, so if we do that real quick, I got 0.875 divided by 2 equals 437 thousandths, which is no big surprise. That's 7/16. Let's copy that. And so this one right here, I'm going to have it come up there, paste. You know, half the diameter of the cutter is fine. I mean, really? Now, I don't need that any of this stuff right here. That's all good. Control S. So, Y is going to feed up. Now, I'm going to do, which way am I going to mill? Well, we want to mill, since the cutter is rotating in a clockwise direction, and the cutter is, we want to be what? Well, we're going to be doing a counterclockwise rotation here on this arc. That would be a G3. So, all I have to do is put in this G3 right here. I programmed it, G3 and a J. Now a J is the only time we really use a J, is so with the J minus especially, is so that we go ahead and get the exact, all right, the exact 100 or 360 degree circle here. And if you don't put the J, that minus symbol there, it won't work. Now this has to be the radius just like it is, so paste. There we go again. Once I got that 0 there that I don't need, Control S. Okay, so I've come up 437 thousandths. Now what we want to do is we're going to go up and we're going to leave, all right, like I said, we're going to leave some stock in here, so we got to use cutter comp. And remember, this is what I meant right here. So I had x0. So there's something I got to add in here. Obviously got an extra f here. Let's get rid of that. So while z come down 240 thousandths, I think I'm going to open up a line right here because it was at x.5. Let's open up a line. We'll resequence, right? Hit enter, go up in, I don't know, 445. That's why we do that. And at this point, we're going to go, we've already got the G1 active, but let's just do it in, actually we don't have it. Yes, let's get this in position. G1, we're going to comp, you know what, I don't want to put it there. I do not. Because I want that to come down, then I want it to mill over. That is correct. So I want to put it right here. I want to open up right here. Sorry, not in 455. Okay, so we've already got a G1 active, but I'm going to put a G1 in there anyway. And this I will put in my G41 because that is going to be cutter comp left. Let's make sure we're right here. We're going this way, counterclockwise. So yeah, that's left. So G41, and we'll have X will move to 0. That will turn the comp on. Not 0, 0, but 0. And then we'll go, of course, I'm pretty sure I want to use the exact same D number that I used up here, which I believe is probably D number 1. Let's take a look. Yeah, D1. Okay, so we go here. Okay, right up here. We're still roughing that in. G41, X0, and we can put in a D1 there. D1, Control S. That'll turn the cutter comp on. Then we moved it up 437 thousandths. Okay. Then we did a full 360 degree arc with a G3 counterclockwise. Okay, I'm not going to write that in there. So what's the next move? Well, once we've done that, we want to move it up again. Now the idea is we never want to go up too much farther. Let's see. The diameter of this pocket's 1 inch 750. So we don't want to move up more than half of that. That's 875. Okay, so let's I'm just going to copy that. Really don't. So let's see here. 437, another 7/16. would be pretty dang close to 835. Matter of fact, it'd be oversized. So I'm not going to move it up another. I think I'm just going to do, let me see what we got here. 437. Let's do that. Try that out. 0.4375. Decimal equivalency 7/16 times 2 equals that, 875. And I already said, if I recall, 855 was what I wanted. So that's not going to work. So you know what? Since I'm roughing and I'm leaving plenty of stock, I'm going to close that out. I'm going to make this number right here just what I thought I was going to do. Paste. Yep. And I got the 2 zeros again. Control S. Then this is going to be that. You know what? 0.875 is quicker than dealing with the 2 zeros. And I still put a decimal point in there. Control S. Okay, that right there should effectively finish that pocket, leaving 20,000 stock. So let's just go all the way down. Let's get rid of these two because we don't need them. Remember, we're going to see resequence anyway. Okay, let's double check what we did. We started at x.5, y0, z.1, cooling on. Then we plunged down into the work 240 thousandths at 4.58 inches per minute. Then we comped over to x0, which we were at 0.5, so that's more than enough, activating cutter comp D number 1. Y moved up to 437. We cut 1. So we did this in 2. We did this in 2 passes. Maybe womp womp. Remember, I'm using a 7/8 end mill. Hey, there's a good rule about end mills, people. Use the biggest one you can get away with. It's just more efficient. It's more sturdy. There's just a lot of good reason to use big end mills if you can. If you don't have big end mills, 7/8 is not really considered a big end mill, really. Okay, then we got our G28. We're going back out of that, turning the coolant off, turning the spindle off. Great. Now, so that was tool 1, right? So the next one down here, this is where we're going to finish it. And I believe I've got that. Activate work off, take the center. This is going to pocket mill finish. So let's go to our Safestart. We're going to do the same thing. Matter of fact, I know exactly what I'm going to do. And you do too. I'm going to copy and paste. Okay. Go back here and here because all of this is good. We don't have to change any of this. I do want to check my spindle speeds and things like that, but I'm pretty sure it's good. I'm just going to do all of this right here and paste this on top of it. Paste. Now you're going, all I do is change that to D2 because I'm going to be using that. This is a 3/4 4 flute end mill. Let me see here. I'm going to leave the feed right like that. I believe that's what I did calculate up. Let's see what the feed was. Every now and then that happens for tool number 2. Where is tool 2? Tool 2. My speed was 356 and my feed was 5.7. So no, I need to go a little faster here. Now let's make this 5.7. I could have copied that, but heck with it. 5.7. Control S if you haven't done that. All right, so we've already opened up a line. We were at 200 x.5. Do we need to be an x.5? Because this is a 3/4 end mill, so it could be x.4. That'll save us a little time there. Control S. And then, Z comes down to 250 because we're finishing the pocket. So let's change that. Control S. Then we're comping over to x0. We're coming up to 7/16. That's not right because we want to go half the diameter. So let's go 0.375 because that's half of 3/4. And again, I did it. All right, Control S. J, of course, is going to be, here, we're getting it now. There we go. Control S. Now, so what's another? So 3/8 plus 3/8 is 750. So it looks like this one, because it's a smaller end, I'm going to take more passes. So this, I'm going to go to 0.75. And that's all I need right there. Control S. And this will be 0.752. Okay, Control S. 0.75 as well, excuse me. Now I'm obviously going to have to enter some other stuff here. So let's go in 500, I guess. That's probably what it was before. Oh, excuse me. Capital. I know that. Okay, so this is going to be a G1. And let me see.
So 750 plus 375, let's double check that out. That may not be something we can do. 0.75 plus 0.375. Remember, that's half the rate, the diameter of the cutter. Each time I'm stepping over half of the cutter diameter. So 375 thousandths. Let me see here. Equals 1 inch, 125. I think I take that times 2. I get, let me see here. That is not going to work. Nope. So I think I'm not, the only pass, it's not going to be 750. Let's try this again, clear it out. Let's go 1.75 divided by 2, because that's where I want to finish at 875. So I would copy that, but I'll get that damn zero again. 0.875. That's only 120,000. That's no big deal. So I got J minus. So this I'm going to be, Y is going to be 0.875. New line. In 510 space, let's do a G3 because it's counterclockwise. That's an arc counterclockwise. And a J minus the same number, 0.875. That should effectively finish that pocket. That's as simple as it gets. Control S. Seriously, all I did, I used the same end mill. Remember, I used this as the 3/4 end mill that I used to finish the outside of this. I also used my 7/8 end mill, which is what I used. So what this is going to do is it's first, it's going to mill the outside. Now you're going, why didn't you just mill the outside then mill the pocket at the same time instead of do the tool changes? Because I did a work coordinate shift. Remember the G55? Yep, right there. I had to do that work coordinate shift. Made the math a whole lot easier, and it's going to make the math a whole lot easier for the bullet hole circles as well, which we haven't done, which we're going to do in another video. So I'm going to hit Control S again, make sure that I've got everything going on here. Yes, that ought to work really well. Okay, so I will see you in the next video, which will be Mill Lab 7A, and we'll do the bullet hole circles and finish this thing up. All right, thank you very much, and have a good day.